Alright, welcome back to our final video of this section on 3x3 systems of equations. And in this video we're going to take a look at systems of equations with an infinite number of solutions. So in the last one we saw no solution where we had at least two of the planes are parallel. In this one, two or more of the planes will be the same plane if we were to graph them. So let's begin. So we'll start with the augmented matrix. Hopefully this will be a little bit easier to see. We got a 1, 1, -2, and a 7. Might even be easier to write, so we'll see. -1, -1, 2, and -7. So -1, -1, 2, and -7. A little delay. 2, -3, 2. And then -2. Alright, so first up, this number is already a 1, so that's good. So let's look at the next row. We have -1, so if we take the opposite of -1 is +1. +1 times the first row is, well, it's just the first row. So we can just add row 1 and row 2 together to create a new row number 2. And if we look at these, notice they're opposites. We could go ahead and say, oh, we're also going to take -2 times row 1 and add it to row 3, but we'll see that this is going to be sufficient enough. So row 2 is the one that changes. So 1 plus -1 is 0. 1 plus -1 is 0. -2 plus 2 is 0, and 7 minus 7 is 0. So once again, if we take a look at what we have an entire row of zeros. So we have zeros on the left, but this time, as we'll see in this section, we also have a 0 on the right. So this second row here means 0x plus 0y plus 0z. So the 0x plus 0y plus 0z equals 0. Well, 0 times anything is 0, so we have 0 plus 0 plus 0. That's equal to 0. So we have 0 equals 0, which actually is a true statement. That's a true statement. And when we have a true statement in algebra, when our variables are gone and we're left with a true statement, that means we have an infinite number of solutions. So in other words, this first row, the plane of it, and the second row, they're the exact same plane. So any point that's on the first equation or on the first plane will automatically be on the second. So for instance, if we have the point x is, let's say 1, y is 0, and that's going to make z -3, that's also on this second one as well. So infinite number of solutions. Again, nice when our variables go away and we're left with either a true or false statement. All right, last example, part B. Part B. So if we draw our matrix, augmented matrix, 2, -1, -2, and then a 5. 6, -3, -6. Then a 15. 5, 0, 4. Again, if you're ever missing a variable, fill it with 0, and then -2. So for this one, we could, we actually could, if we want to. We don't have to get this one equal to 1, because if we notice, this times -3 gives us this times or this times 3 will give us 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 this. If we take, just as another way of doing this, if we take the first row and multiply it by -3 and add it to the second row, we can make that our new second row. Or we could divide everything in the first row by 2 to get a 1 here. I mean, just like we did in the last video. But just to show you that there's another way you could do it as well. So it's not just one way, my way or the highway in this case. So a lot of ways to solve problems. So if we take negative 3 times 2 is negative 6. Negative 6 plus 6 is 0. Negative 3 times negative 1 is 3. Negative 3 plus the 3 is 0. Negative 3 times negative 2 is 6. 6 minus 6 is 0. And then 5 times negative 3 is negative 15. Negative 15 plus 15 is 0. So once again, we do get a whole row of zeros. So if we have a whole row of zeros, it's not going to matter what's in our first and third row in this case. So once again, we have an infinite, whoops, forgot to switch out to, we have an infinite number of solutions. In other words, the first equation is a plane. It's the exact same as the second equation. They're the same plane. So, all right, that about does it for this video. Thank you for watching. I will see you next time.